Hello students, so up till now we had discussed about center of mass. We have solved the questions based on center of mass. What is center of mass, how to calculate center of mass, and in the last video we had also seen the shift in center of mass, right? Okay, so we can say now we will start with the new chapter, that is rotational motion, or you can say rotational dynamics, right? Today we are just going to see the introduction of this rotational motion, right? And in this particular chapter we are going to learn about variables, angular variables, like what is angular displacement, angular velocity, what is the meaning of angular velocity, right? What is angular acceleration, what is torque, angular momentum, moment of inertia. So very interesting topics are included in this chapter. Of course the chapter is not hard, you just have to follow the sequence and you just have to prepare according to the sequence, right? Okay, so this chapter is rotational motion, or you can say rotational dynamics. Before starting with the chapter, let us just recall about the types of motion, like what is translation motion, what is linear, curvilinear, what is rolling motion, what is rotational. But before that we'll know what is a rigid body. What is a rigid body? Rigid body is an ideal concept where you can say that a body which cannot be deformed by any means. Any body having any solid body which cannot be deformed by any means, that is defined as rigid body. Or it can also be defined as if the relative position of the particles inside the body remains invariant, then such a body is called a rigid body. Of course, it's an ideal case, you cannot have any body as rigid body, but generally rod, disc, we can consider them to be a rigid body. See, what a rigid body is defined as: the relative position of the particles inside the body remains invariant. That means if the position of the particles inside a solid body, if it is not changing, if it is remaining the same, then such a type of body is known as a rigid body. Or you can also say that a solid body which can never be deformed, right? So this is what is a rigid body. Of course it's an ideal case, an ideal concept, but we can consider in our case solid body as rigid body, no problem. Solid bodies as rigid bodies. Clear? Solid body, right? That means any solid body is made up of its constituent particles, right? If the distance between two particles is not changing, then that is a rigid body. Okay, now before starting with rotational motion, let us discuss what is translatory motion, translation motion. Already translation motion. Translation motion are of two types: rectilinear or linear, curvilinear. Right? What is, first of all we will say what is translation motion, right? And then the types of translation. Translation motion means, suppose let us take a solid body. This is a solid body. It is made up of many particles. Let us consider three particles like this: A, B and C. Now suppose this is a solid body or a rigid body. These are the particles inside a solid body. If the motion of the particles if the motion of the particle remains parallel with each other this way. That means suppose this solid body is moved from a position 1 to any another position, say 2. I am moving this solid body from position 1 to 2, right? So this A particle have moved this way, B particle must have moved this way, the C particle have moved this way. So this particles have performed parallel motion with each other, with respect to each other. This kind of motion is known as translation motion. Once again, translation motion is classified into two, rectilinear or linear and curvilinear. First of all, what is translation motion? If inside the solid body, the particles inside the solid body will perform the motion remaining parallel to each other, then this kind of motion is known as translation motion. That means suppose a solid body is being moved from position 1 to 2, it's being moved from position 1 to 2, right? Then the particles inside the body A, B and C, these are the three particles which are lying inside the solid body, they have performed the motion parallel to each other. They have moved parallelly with respect to each other, and this kind of motion, this is known as translation motion, right? Now in this case I have moved the body on a linear path. That means the body has definitely moved, but it has moved linearly. So that means if the particles are moving linearly and remaining parallel to each other, then this kind of motion is known as rectilinear motion or linear motion. Rectilinear motion or linear motion. That means if these particles are moved on a straight line, that means if this body is moved from position 1 to 2 this way, that means I am moving the body from 1 to 2 this way, I am moving the body linearly. So of course the particle inside the body must have moved in straight direction, right? So this kind of motion is known as rectilinear motion or linear motion. That means when the constituent particles of the body move in a straight line remaining parallel to each other, then that is known as rectilinear. So it is a type of translational motion, but it is not necessary or it is not always required that the body should or body will be moving in a straight line. Sometimes this solid body, if suppose this is a solid body, you can take off any shape. These are the three particles A, B and C. It is at its first position. Now if this solid body is moved from position 1 to 2, but now I am moving this solid body this way or say this way, this is how the solid body is being moved, right? So suppose if I am moving this solid body this way, then the particles have not traveled in a linear path, they have moved in a curved path, right? So this kind of translational motion is known as curvilinear motion. Curvilinear motion. Clear? Right? So once again, translation motion means the motion in which the particles of solid body are moving parallel to each other when motion is done, and if they are moving in a straight line, then this kind of translatory motion is known as rectilinear or linear motion, and if moved in a curved path, then that is known as curvilinear motion. Clear? Okay. Now what is a rotational motion? What is rotational motion? Rotational motion means if all the particles inside a body, inside a solid body, moves, if all the particles inside a solid body moves in a circular path, then this kind of motion is known as rotational motion. in the starting of the chapter, this kind of definitions and theories are there, which are of course a bit boring, but we don't have any other option now. If all the particles inside a solid body moves in a circular path, right? Let me say I am taking a disc. I am fixing this disc. Any body, you can take any body. Let us take ring or disc, whatever you want. Right? The body is being fixed from this axis. Now if I am moving this body, now if I am moving, okay, if you are not getting this point, we can consider this one also. This is a body. Okay. A better way to explain. Let me take in horizontal. This is a solid body, right? This is the axis. This is the axis, right? Now this is the body, this is the axis which is passing perpendicularly. Now if the body is being allowed to move this way or this way, then all the particles of this solid body will be moving this way, right? That means all the particles of the body will be performing circular motion along with the body, and this kind of motion is known as rotational motion. Once again, rotational motion means, suppose this is any solid body, these are the constituent particles, 1, 2, 3, 4. If the body is either moved this way or this way around this axis, around this fixed axis, then all the particles will also perform this kind of motion. That means all the particles lying inside the body will perform circular motion. Then such a kind of motion is known as rotational motion. Right? You can also have this way. There is a disc over here. You are fixing one point, or you are passing an axis this way. Now if the body is rotated this way, then all the particles lying over here will be moving this way. That means all the particles of the body will be performing circular motion. This kind of motion is known as rotational motion. Of course, if a body needs to perform circular motion, it is not required that it has to be pivoted or it should be rotated about a fixed axis. It is not a compulsory thing. You are getting the point? First of all, once again, what is rotational motion? When all the particles of a solid body are moving in a circular motion, then such a kind of motion is known as rotational motion. That means if this is a body, this is an axis, right? If the body is either moving this way or this way, then all the particles of the body will be moving in a circular manner. This kind of motion is known as rotational motion. You can also understand this rotational motion like if this is the body, I am fixing it here, and then if the body is rotated or if the body is allowed to move this way, then all the particles will be moving in a circular path, and that is known as rotational motion. Clear? But for rotational motion to occur, it is not necessary that the body should be pivoted from a point. It should be fixed from a point. That is not required, right? That means if simple, you can take this example. If you are having a pen or a pencil, right, and if you are applying a force at the end this way, if you are applying a force, then also it will rotate about its center of mass. So then it is not being fixed. The pen is not at all fixed with any of the axis, right? So for a body to perform rotational motion, it is not required that it should be pivoted. This is just one of the case of rotational motion. Here, in this case, if I am hitting the pen from the end, from one of its end, it will perform rotational motion. So pen is not being fixed. It is not at all fixed from any of the axis. Still, it is performing rotational motion. Clear? So to perform rotational motion, pivoted axis is not a compulsory thing. Clear? Okay, now let us see what is a rolling motion. Of course, rolling motion is not required now, but suppose, okay, this is a surface having some friction, right? I am just giving a force to a coin, I have just placed a coin on the surface of the earth and I am just applying a force like this. Coin will have combined motion. This kind of body will have combined motion. It will move in forward direction, also it will rotate. Is it so? Suppose take any coin, or you can take any top of your water bottle, right? Just keep on the ground by applying a force this way. The body will be performing this kind of motion. That means body will be moving ahead as well as it will be rotating, right? That means it is performing linear as well as rotational motion, right? So rolling is actually combination of two motions. Rolling motion is combination of translation motion plus rolling rotational motion. A combination of these two is known as rolling. That means body is from point A, body is coming to point B. That means it is moving in linear direction as well as it is rotating. Clear? So this is, we'll study about rolling motion in our topic, rolling without slipping, but this should be known to you that rolling motion is a mixed motion, a combination of translatory motion as well as rotational motion, right? Okay, now we'll discuss few angular variables. Of course, say in the chapter motion in a straight line, you must have gone through displacement, linear velocity, linear acceleration, momentum, force. These were all the quantities related with linear motion. Now we are going to discuss about all these quantities but in a rotational manner. That means these are known as rotational variables. They are known as rotational variables. See, we had discussed about linear displacement. Now we will discuss about angular displacement. We had discussed about linear velocity. Now we will discuss about what is angular velocity and what is the formula of angular velocity. Angular is a word associated with a body which is performing rotational motion, right? Linear acceleration, angular acceleration. Okay. So turn by turn we will understand what is angular displacement, what is angular velocity, what is angular acceleration. Clear? These are all known as angular variables. By knowing about these quantities, we can come to different formulas, right? Like torque, angular momentum, moment of inertia, right? Okay. See, suppose there is a circle, let us say R be the radius. Let us consider a particle over here. There is a particle at point A having a mass m. It is moving on a circular path. Let us say at t equals to t1, particle is at A. With any speed v, with any constant speed v, particle is moving on a circular path. After any time t2 or at any time t2, particle reaches at a point B. So, particle has undergone two kinds of displacement. That means particle went from A to B. So this is the distance it had covered. This is the distance it had covered. But apart from this, this is the change in angular. This is the change in angle, right? That means suppose you are watching any, say, car race, or you are watching a bike race in which the racer is moving this way. It's moving this way, right? That means you have to change the vision also. That means if you are seeing here, suppose the bike is at this position, so I am standing over here, so I will be looking this way, but when the bike turns and moves over here, then I have to change my vision this way. I have to look this way. So first the bike was at this position, so I was looking this way. Now the bike has moved from point, say any point A to point B. So then I have changed my vision. I have changed this my face from this to this. So there is a change of angle. This is known as angular displacement, and this will be known as distance. Clear? So actually the bike racer has travels or has undergone two kinds of displacement. This one is linear, and also this is the change in angle. This is a change in angle. So first the bike racer was at this position, then it had moved over this position. So I have to look this way. So this is the change in angle. This is the change in angle. This is known as angular displacement. Let us understand mathematically. See, suppose let us say the particle is at this point, or we'll say bike racer. Bike racer is here at t1 time. I am looking from this point. I am looking from this point. I am looking from this point, right? So this is the initial angular position. This is the initial angular position denoted by theta 1, right? So theta 1 is initial angular position of this racer, right? Bike racer. Now it is performing, or it is moving in a circular track. So say at any time t2, it had reached at a point B. So now looking to the bike racer, this will be my final angular position, theta 2. Clear? Bike racer was here at any time t1. After any time t2, or at any time t2, it had moved from point A to point B. So this will be my final angular position, theta 2. Theta 1 will be my initial angular position. So theta 2 is final angular position. Okay. So what we had studied in linear displacement, it is final position minus initial position. So similarly, angular displacement of bike racer will be equals to final angular position minus initial angular position. Just as the same definition we had used in calculating linear displacement, final position minus initial. So this will be theta 2 minus theta 1. So delta theta will be termed as angular displacement, right? So angular displacement. Now theta, so unit will be radian. Theta is measured in radian. So angular displacement will have a unit radian. It will have a unit radian. Now if you are being said that the particle is moving on a circular path of radius r, and it is completing one complete rotation. It is completing one rotation. So what will be the angular displacement? 360, 2 pi. It has started from here, 90, 180, 270, 360. Clear? So angular displacement will be 2 pi, 360, but linear displacement will be 0. Linear displacement will be 0. That means, see, if I am saying that particle is at this position, it is completing one rotation. So that means it is moving from point A, point B, point C, and then returning back to A. So angular displacement will be, see, this will be 90, 180, 270, 360. So this will be 360. So angular displacement will be 2 pi radian, but linear displacement will be 0. Now if you are being said that particle is moving from A to B, particle is moving from A to B, that means it is completing half the circle. It is completing half the circle. Then what will be the angular displacement? This will be the angular displacement, which is equals to pi. Which is equals to pi. And if it reaches at this point, angular displacement will be 90. Right? Second thing, if in question you have been given that a particle is moving with, or a particle is having an angular displacement of 2 revolution, then you will have to convert this into radian, right? So unit of angular displacement is radian. It is not rotation or revolution, but it means we can definitely specify the unit in revolution and rotation, but this is the conversion, that 1 revolution is equals to 2 pi radian or 2 pi rotation. So in many of the cases, if they have given theta, angular displacement in revolution or rotation, then multiply the value by 2 pi and you will have to get it into radian. Clear? So this was all about angular displacement. So now in the next video, with the help of this angular displacement, we will understand what is angular velocity, what is angular speed and angular acceleration. Clear? Thank you.